All right, welcome to chapter 5. It's called normal probability distributions here. So this is a cool transition chapter from probability and into statistics, or the stuff that we're going to use. And it involves something called a normal distribution probability. It's super duper important that we get this because pretty much chapter 6, 7, the rest of it is based upon this right here. And so I think in my mind, chapter 5.4 is probably more like the just the genius section, because it's the whole concept of how do we standardize all data. So if we have, let's say, a distribution of all weights of women in the United States and the distribution of all men weights in the United States. The question is, how do you compare those two together? And that's what a normal distribution is. And so we will work with it. We're kind of just going to do the beginnings of it, and then we're going to go from there here. So what are we going to learn here? So just an intro to the normal distribution, and then we're going to do things. So we're going to use this to find the probabilities, and then we're going to go backwards. So this is the forward and backward here. Then we're going to go find the values of them. And then 5.4, we put it all together. Like this is the way, this is how it's going to work for the rest of the semester. And then we got one more thing to do. 5.5 is this whole concept. What happens if we do something called binomial distributions? Binomial distribution just means you have two choices, either yes or no, success or failure. That's kind of how we're doing. So it's a yes, it's an on-off sort of thing. What happens if you have just two options? How do you do a normal distribution? And normal distribution is, it assumes we have continuous numbers. That's what we have here. Okay, so let's jam. Let's jam with it here. So 5.1, all yours there. If you want to write it down, haven't done it yet. Intro to normal distribution. All right, then we're also going to talk about the standard normal distributions. So got two things on our plate. We've seen this graphic before. We're just going to kind of dive deep into it today. All right, let's jam. So first things first, we got to think about this whole concept of a continuous random variable. Think about that here. So the word continuous is important to us here. Continuous just means you can break stuff down into its little tiny pieces. So hours of the day is probably a good example. Hours of the day, you can break up days in, hours into minutes, right? Minutes back down into seconds. Seconds, you can go down to a millisecond, a nanosecond, right? So these things are just kind of, you can chop them up into an infinite amount of pieces. So that is a continuous random variable. That's what we want to think about. All right, don't need to do the graphic or anything, but I think just the stuff that I highlighted is probably what you want to be writing down. The extra stuff is just for us to think about. So yeah, don't need to do the graphic. Don't need to put the stuff in on the side of in the red font. Okay, so what we're gonna do, if we have a continuous random variable, what we want to do is we want to also do something like this, because something called the continuous probability distribution, which means I'm going to figure out all the probabilities that are possible. Okay, how we do that? How do we figure out all the different possibilities that are possible and then distribute it across? It's almost like, let's see, good example would be a coin toss would be, a rolling of the dice would be possible, right? So all the different possibilities of rolling of dice, all the probabilities of that happening, or maybe like the sum of all the dice, or 2 dice and the sum of the numbers. That probably be a good one here. So then you're writing all the different possibilities. How do we do that? We do that through a normal distribution. So here's what it looks like. It's called the normal curve. And I'm going to actually just jump to this one right here. That's the one that has the. We're going to start drawing things that look just like this. A normal distribution just means it's all the different probabilities are listed right inside here. Here's all your different possibilities something can happen. The mean, median, and mode are all equal. They're all down the middle right here. That would be a normal distribution. Another thing is it's a bell-shaped curve. It goes up, comes down, and it's symmetric, which means both sides are the same. This is kind of like the graphic that we're going to use a lot. We're going to shape all our data into something that looks like this. All right, even the data that does not look like this, that's what 5.4 is all about. That's what we're going to do. We're going to shape it anyways back into this. Some data actually already looks like this. A lot of data is normally distributed with the middle sort of bunching up, going from there, and no matter what the scale is. Okay, the other thing is there's 4 here. So the total area, this is important here. The total area, all the stuff in blue, that's under the curve is equal to 1. That's the way we defined it. And then the other little thing, which is interesting, that there it is, the total area is 1, all the blue stuff. And the next thing is on the ends. On the ends, we have something called from algebra, a horizontal asymptote, which means the ends actually never touch the x-axis. They just extend farther and further and further out. So there's our 4. We're going to add one more little detail with number 5. So there's our 4 properties of the normal curve. We're going to use this a lot. We're going to use it in chapter 5, extending in chapter 6 and 7. Like this is the graphic. So we're going to get used to it. Let's see, maybe if you have not made a graph of it yet, maybe hold on until number 5 and underneath it, make a little graph of it. So we'll make a little picture of it as well, this one particularly. So normal curve, normal distribution, there it is. Now, one more, we're gonna add a little more detail to the graphic here, just a bit. All right, what happens is we don't, let's see, a lot of times, a lot of things come close to a normal distribution. Like I said, weights of men in the US, if you were to get as much data as you possibly can, usually would find that's normally distributed. Okay, one more, since I see people almost done. And tell me if I'm going too fast, I can go back. That's no problem by me. And we're gonna add one more detail to our graphic here. Something looks like this here. And then I highlighted the bottom here because it's a lot of more math stuff on top. But the bottom, it says the points at which the curve changes from curving upward to curving downward are called inflection points. So notice the curve starts high and it's kind of going lower and lower and lower. And all of a sudden it starts bending the other way. It's bending down over here. It starts to bend upwards here. And that's called an inflection point. The interesting thing is that inflection point is exactly where you have a standard deviation of 1 away from the middle. That means now less and less people are getting into this area here. So don't need to do all the stuff there. Not highlighted, just the highlighted pieces. And let's do some examples real quickly here. Okay, so this whole concept is here. So the middle, the mean is this little part right here. It's where the graph goes upward. And it's the center of the graph here. Then you have something called standard deviation. And remember from chapter 2, standard deviation is just how much spread you have, right? How wide is it? So just a quick little 2 examples on this. I'm gonna go here, and so don't need to write it down, just kind of think with me real quick here. So question is, which curve has the greater mean here, A or B? Let's go with raise your hands for A. Raise your hands for B. So the greater mean is the middle of it, right? That's where the graph goes up to the highest point. So it looks like the mean for B is 12. And the mean, the middle or the average for A is 15. Are we good? A wins over B. Is that good? Okay, there's that whole concept of mean. So where the height is. So curve A has the greater mean if we're just talking about that. Which one has the greater spread? Or the standard deviation? I say B, is that right? Yeah, B is a lot more flat and it's way out here, right? Where A is a lot more condensed. So curve B has a greater standard deviation. There it is. There's kind of the difference between the two. The bump is the mean, the spread is the standard deviation. So let's take a look at an example where we have a normal distribution. Again, don't need to write it down, kind of think with me here. We'll do some examples in just a bit. Scale test scores. Here it is for New York State. This is adapted from the New York State Education Department. There it is, the Common Core Mathematics test. As was integrated, what, 5 years ago or something? Did you guys do Common Core when you guys were in high school? It was like Math 1, Math 2, Math 3. Dude, show of hands, how many liked it? Show of hands, how many did not like it? Okay, how many did not do Common Core? Because they're from a different state and they were not from California that adopted it. Okay, gotcha. Okay, cool. Yeah, there was Very contentious when it was being adopted as well. All right, the normal curve shown below represents this distribution. There it is. Does it look like a normal curve? Absolutely, right? It looks like a normal curve. You got a lot of the students getting some. What looks like the mean here? Tell me the mean. Anybody daring enough? Cool, yeah, let me zoom in here. Yeah, about like right there-ish, huh? And these scales, what's the scales go by? Is it by tens? Yeah. At 340, that would be 340, 350, 360, 370, 380. Okay, yeah. So 320, 310, like right here-ish, huh? Okay, I'm thinking, yeah, about 305. Was that good? So there's my about 305. Looks like is the mean. You guessed it about there. And then I kind of slowly disagreed here a little bit. I thought the other graphic should have pointed a little bit the other way, but now that notice the curve here, the curve goes out down. And the question is, you got to sort of eyeball it. When does the curve change from curving downward to kind of change to curving up? And it seems like it's about right there. We good? So if you drop this down or something close to it, what is that? That's 280, 270, 265. So then 265 to 305, that's about 40. So then we have a standard deviation of 40. Are we good? If we think back all the way to chapter 2, do you guys remember anywhere from 265 all the way to what, 345, right? All this stuff here. How much percentage-wise, what percent is right here of the area? So close, 68, about 68%. Yeah. Very rough estimate, 70%-ish, right? But 68% is what we're talking. Okay, just real quick here. There it is. There's a scaled score, 4th grade math test, and it's a normal curve. There it is. So just to remind ourselves of chapter 2, here it is. So you know, one standard deviation away, 265, 345 is going to be 68%. If you go another 40 this way and another 40 that way, you'll now capture 95% of the data. And then you go another 40 this way, another 40 that way, then you're looking at 99.7%. You pretty much have all the data. And you're looking at the outliers after that. Okay, so that is called a normal distribution. A lot of things have normal distributions, and we work with normal distributions. But we want to go one step further. We want to go to a standard normal distribution. And this is what this looks like. And yes, now you get to write again. A standard normal distribution. It's just like a normal distribution, except the mean is exactly 0. And the standard deviation is exactly 1. And it looks something like this right here. It's the same exact process that we had before. And kind of stretch it out all the way to like a -3, right? Because from -3 standard deviations away to positive, that's about 99.7% of the data right here. So make a little bump in the area, and the middle should be right at 0. And if you want to put area equals 1, just to remind yourself of that. And so now the question is this. How do I go from a 4th grade mathematics test scaled score back to a standard normal distribution? And so we have our ways. So how do I go from an average of 305 on the math test so that that 305 really is the 0 marker for me? And so what you do is we're going to scale back the mean to 0. And the standard deviation, we want to scale back to a 1. So that's what's called the standard. So here's what we do. We're going to take any X value whatsoever. We're going to transform it by this little formula right here. And we call it a Z-score. The Z placement, and Z is just the number right here, somewhere along the X-axis. So what we do is we take the X value, we subtract it from the average that we had before, or the mean, and we divide by standard deviation. So that means it just standardizes everything. Which is super cool. And this is probably like the crux of statistics here. If you're understanding this, makes much more important to understand the rest of it here as we get into other things here. Very foundational chapter. It's kind of like, you guys raise your hand if you had chemistry before. Anybody chemistry? Cool. Okay. In chemistry, I think what's the crux idea in chemistry 1A or introductory chemistry is this concept of a mole. How many understood what is a mole in chemistry? Okay, that's like, if you understand that, everything made sense, because everything's based on, that's the crux of the matter. If you just couldn't get a handle on it, you were just memorizing formulas for no good reason. You know, some people said, yes, I was memorizing formulas. Okay, so there it is, our standard normal distribution curve. That's so cool. Real quick here, you guys talk to me here. How much area is from here to here? %68% right here. So 68% of the area is right there, bound up right there. How much of the area is bound up from here to here? Yeah, 95% of the data is sitting right over there, right? And so the area is, that means only really 5% is sitting on the outskirts. Hey, real quick here, that's interesting too. So if 95% of it is here, right? How much is on each of the sides? Hey, that's right, because you have to split the last 5% into two pieces, right? So it's going to be a 2.5 on here, and then a 2.5 here. We're good? And so we have these standard z-scores that we're going to start using here. So z-score of 1 is important, z-score of -2, z-score of 3. So now the question is this. Let's just do a few things here. Some properties here. Oh, let me jump to this one here. So something called the cumulative area. Let's talk about cumulative area first, and then we'll kind of work our way through. So there's 1, 2, 3, 4 properties. We're going to talk about the standard normal distribution. First things first. Cumulative area. What does that mean? It means the area up to the z number. So first things first, the cumulative area. What's the area less than -3.49 z-score? We say pretty much it's just 0. Once you go beyond a z-score of -3.5, there's not much area left. Okay, are we good there? Let's go back real quick here. Let's kind of do a little bit of work in our minds here before we get to the next properties here. So think with me, don't need to write it down. Let me jump back to what we had before. So We talked about cumulative area. So first things first, cumulative area just means if I'm at a z-score right here, cumulative area just means anything that's up to that area. Okay, so at negative 3.49 or negative 3.5, we say there's no more area behind that z-score. So question for you guys here. So this is 68% of the data, is that right? Gonna do some math here in just a second, okay? This is 95% of the data. And that's 95% of the data. We split that in half, right? So 2.5. Let's see, let's split this in half too here. So 68% is 34% here, 34% here. Somebody on the calculator, just real quick here, do this for me. Let's go 95 minus 68. How much? 27. Then divide that by 2. Okay, so you guys talk to me if you guys agree here. So there's about 13.5% here and 13.5% here. Tell me if that makes sense to you guys in your mind, right? Okay, we're good there. I'm gonna erase it in just a second here. Okay, so we got 13.5 here, 34 here, and the leftovers over here. So let's see what the leftovers are. Let's see, 50%, you guys talk to me, tell me if you guys are true. 50% of the data is gonna be right here, isn't it? Okay. So tell me, do this one for me now. 50% minus I got to do some work here. 34, sorry guys, 34 plus 13.5. What is that right there? 47.5. Okay, 47.5 minus 50, or 50 minus 47.5. 2.5. Oh, that's right. Yeah, duh. That's what we talked about last time here. So 2.5 is left over here. We good? And 2.5 is left over here. So I'm going to erase this now, leave these percentages in, and let's talk. So there's my little pieces that I've got here. So cumulative area just means up to the z number or lower. So you guys talk to me, or what is the cumulative area of a z-score of negative 2.00? So that means how much area is up to here or lower? 2.5. We're good, 2.5? Awesome. So z-score of -1. How much area is in the z-score of -1 or lower? %16. Are we good? Yeah, perfect. Okay, and then just one more, maybe two more. So what is a z-score of 0? What is that even talking about? And what is the area? Say again? Good try. Oh, cool. Zero says 50%. Is 50% okay with you guys? Good guess though. No problem. We can make mistakes in the class. That's no problem. Okay, yeah, z-score of 0 means you're right here. You're actually right in the middle. So what percent of the data is falling less than z equals 0? 50%, exactly, because we're right at the center of it, right? Okay, so how about this one here? How about, okay, guys, talk to me about this. No, that's not a good one. 2.0. Haha, I gave you guys one that you actually have to do. Say again? 97.5. Anybody agree or disagree? 97.5, which means I have all this data. I can add these up, or I can say, hey, look, I am just missing a 2.5% from 100, right? I'm missing 2.5. That's 97.5 because I'm just missing the 2.5 to get me to 100. Okay, so this is how things work here. So let's practice a little bit here. Let me go back real quickly here. That's cumulative area. We good? That's the concept of cumulative area. It's up to the z-score or lower. Okay, let's jam now. Number 2, the cumulative area increases as the z-score increases. True or false? Does that make sense? Yeah, as the z-score gets bigger, the area gets bigger. Of course. All right, next one. I think we already talked about this one here. A z-score of 0 is really just, and we don't really talk about it as percentages, as about pieces of an area, right? So instead of 50%, we talk about as 0.5, 0.5 of the area. Okay. And last one here, number 4, the cumulative area is pretty much, we say, close to 1. If you're at z-score of a 3.49, and I don't know why they don't make it like 3.5, like why would you be 100th off, right? But 3.49 pretty much just says, look, I have all the data. There's really nothing to be added beyond that 3.49. Okay, since we're going to use this, and this is such a crux, let's learn how to actually find values here. So if you have your textbook with you, I'm not sure if you do, but if you do, if you want to take it out, we'll kind of do it 2 different ways here. We'll do it by the textbook version, and we'll do it by the calculator version, both ways. So real quick, out of curiosity, raise your hand if you have a textbook with you. Cool, okay, 1, 2, we'll just do it real quickly here. Those that have calculators with them, you're gonna have to do it one way or the other. We're good? So pick a side eventually. Okay, so let me do it by textbook first, and then we'll do it the next go around. First things first is this one right here. So we're gonna find the cumulative area that corresponds to a z-score of 1.14. So inside your textbook, one of the things you should have is all the way at the end, you should have table. And table 4 in your textbook, yay, it has something called the standard normal distribution. It's the strangest, awesomest thing. Okay, in fact, when you open it up, you find out there's actually 2 table 4 tables. There's one right here, and then if you open up like this, you get 2 of them. Dun, 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 dun. That's no fun. Maybe it is, we'll see. Okay, one side actually has negative z-scores. So it's actually less than 50%, we're good? One of them has, and the other one has positive z-scores, which means you're above 50% on the scale. But still the cumulative area is still that z-score and to the left, we're good? So real quick, like, if you get a z-score of 1.15, you guys talk to me, more than 50% or less than 50%? Yeah, you're looking for more than 50% at this point. So the way you read it is you go down the column and you're going to find 1.1. So down the column for the z-score, can you find 1.1? So this is the table, second table for table 4, and it has the positive z-scores. So right there. So we're now, oh, you just flipped it right there. There you are. Cool. 1.1 along the column. And then you're going to look for, and then across the top is all the hundreds place. So I'll show it to you guys in just a second here. I just want you guys to try it. Those that have a book to try it themselves. So 1.1, you scroll across to find the 0.05. Okay, those are the don't have a textbook. Let's go with it. We'll do it together here too. So you're going to look for this little symbol right here first on top. It's the one that's more than half. Notice the positive z-scores are positive. And so the units place and the hundreds place are in the columns right here. So go to 1.1. And then you scroll across for the last little part. The last little part just adds the hundreds place, so 0.05, and voila, that little connection between the two gets you 0.8749. We good? Boom. So roughly at this point, 87.5%, right? And that's kind of, we should think about it. Decimals should be converted to percents really easy in our minds. Okay, are we good there? Cool. All right. Those of you with a calculator, now let's take a calculator out. So you should kind of be familiar to do both, right? You should be able to do the, so calculator's out, let's go with it. How do we do it by calculator here? And I'll walk around to make sure we can do it together here. So TI 84 plus TI 83, I have a TI 83, so I'm gonna try it this way here. All right, so I'm gonna go like this. Let's say I'm gonna go like this. And there it is, okay. Just little, there it is, okay, cool. All right, you guys can work a little bit differently, but TI-84s and the TI-83s are gonna work very similar here. So first things first, turn it on. Second of all is you're gonna go to, it's gonna be distribution. So it's right over here, DISTR, distribution. You have to click the second function to get there. Now, if you have a TI-84 plus, it's going to actually take you to a whole new menu that you're going to input stuff. So what this does is this kind of cool. It tells you what's the beginning Z value, what's the end Z value, what's your mu, and what's your standard deviation. So you got to enter 2 Z scores all the time. So the one we want to pick is this one right here. So the normal curve distribution function, normal curve distribution function. Click enter. So T84 people, you're going to go to a different screen when you do that. And that's okay. We're going to enter the same. So first things first, all the cumulative scores, since we're going off to the left, I'll help you guys just a second. Here's a funny thing. I'm going to put in negative 10,000 because I want to go to the far, far left of my Z score. We good? And I want to go all the way up to 1.15. Put another comma in. My mu is 0 and my standard deviation is 1. And click close off that parenthesis. Click enter, and you should have something that we just got before, 0.8749. We good? Let me walk around real quickly here. And let me make sure everybody got that by their calculator. And if not, let me help you. Okay, boom, boom. And that's what we should get on the calculator right over here. So normal distribution, the T84 plus has a different menu than when you enter it. But anyway, essentially the same stuff. That's cool. Okay. Try one more time. Let's go with a negative Z score this time. So number 2, all yours here from beginning to end. All right, give you guys 20 seconds-ish before giving you the answer. Go for it. All right, what'd you guys get? 40. Okay, gotcha. Sum looks like this, 0.4052. So notice the Z score is always 2 units of measurement, right? 2 decimal places, right? 1.52 or 0.24. The area is always 4, and it's always rounded. So If you were to do it by table, you would do the other 4 table where you have the z-scores that are negative right over here. You got to use this table, the negative z-scores by table. And then if you did it by calculator, you would have put in something like this. Negative 10,000 still again, because we're just looking at the area left of it. We're going to go up to a negative 0.24. The mu is 0, the standard deviation is 1, and click on it and you're good. Notice the calculator actually gives you not a 2 in there, it gets you a 0.405165. So just round off to 4 decimal places. Always okay. Just a quick little hands up, hands down, hands up if you got it. Cool, all right. Hands up if you just need a quick little help. Cool, okay. Because that's what you guys are here for. If you guys knew this stuff already, you would not be here. We're good. Okay, let's do 1, 2, 3. Let's do 3 different versions of this. We'll use the same exact numbers. So first things first, let's do the easy one. We've been doing a cumulative area, right? We've been doing area to the left, right, of the z-score. But sometimes we don't need that. Sometimes we want the other way. We want the right one. Sometimes we want in between 2. So let's do this here. Can you find for me, and again, this is you guys doing it. Can you find for me? Oh, that's no fun. Okay, yeah. Real quick, another one. Can you find for me the area of standard normal table area that is less than the z-score of 1.23? Let's do that one. Again, not to write anything down. Let's just take the 3 different steps that we take. And yes, it is so much easier to do it by calculator. So let's kind of just do the calculator thing. If you do it by table, there's a little more things that are involved in it because you have to subtract areas and stuff. Okay, let's practice. Go for it here. So give me the answer when you guys get it. What's the area at the z-score of 1.23 or less? I accept shout outs, no problem. Something at 0.8 something something, right? You guys are cool. You guys are. So 0.8907, is that right? About right? Yeah. So let me do it. Actually, let me do it on a calculator as well, just so I can do that. I should do these by calculator as well, just so you guys can see it here. So again, T84 is going to work slightly different. That's okay. Boom. Normal curve distribution function number 2. The lower one is negative 1,000 because I'm going off to the left, or negative 10,000, whatever. Just kind of put in a big number. If you put in a negative million, you're fine. Just something that's like really, really low number. Okay, comma. You're going to go up to 1.23, comma. Our average is 0. Our mu is 0. Our standard deviation is 1. Click enter and voila. 0.89065, so 0.7 is what we want. Boom. Okay, let's go the other way then. My question, or here it is, and there's my z-score, 0.08907. Okay, sometimes we want actually the area to the right. So here it is. Can you tell me what is the area to the right of 1.23? Let's do it the easy way first. You guys ready? The super easy way. Did you guys get the area to the left of 1.23 already? Oh, we have it on our calculator, don't we? What was it again? 0.65, right? So 0.7. Okay, so how about this? Since I already know the left area, can't I just do this? 1 minus 0.8907. Is that good? Since I know the right, the left, since I know the left, the right is just going to be complementary, right? It's away from 1. Cool, but if we want to do it this way, if I did not know that, so let's go for it here. So let's go distribution function, normal curve. Okay, so this time my lower one is actually 1.23. All right, that's where I start from. Where do I end? Yeah, I don't. So let's pick a humongous one. I mean, if we pick anything above 3.49, right? Remember that 3.49? That's going to be plenty, right? But just in case, let's go out to 1,000. That's fine. If you want to go to 10,000, that's fine. If you want to go to 100,000, that's fine. Just pick a big old number because calculators don't think, right? They're just tools for us. Okay, our middle is 0. Our standard deviation is 1, and click on that. We better get the same answer that we got earlier. Is that the same answer? Yeah, 0.1093, right? Because it has a 49 after that. So it's like, so that's cool. Okay, if you want to write that down, go for it. Some people want to write down the buttons that they use in a calculator. That's fine too. That's something you want to do real quick here. Or if you just want to write down the main button so don't forget 2 days from now. Okay, and the other one. All right, the other one. How about if I want to find the area in between? Oh, let's finish up this one now here. So you could have just subtracted from 1, which is what we did. Or you could have used the calculator. Any which way, you would have got 0.1093. Cool. Next one. I want to figure out the area in between 2 z-scores. In between a negative 0.75 and a 1.23. Okay, if you're going to do it by table, you got to do a lot of stuff here. You got to think about what's the area to the left, subtract off the area you don't want. The calculator makes it a little bit easier. So I'll let you guys guess. Risk takers, I think you probably will figure it out very easily. So what should we do? You guys tell me, what should we do? Say again? Yeah. Awesome. Uh-huh. And there's actually, it's kind of funny. You can do arrow keys over here like this, right? You can do arrow keys and you can go down to it, or you can actually, that's why the numbers are here. You actually can click number 2 here. Look at this. I'm already down at 0 over here, whatever this is. But click number 2 will actually get you the menu option. So, okay. What's my lower bound? Absolutely. Negative 0.75 is 0.75. If you want to include the extra 0, that's fine. That's cool. That's what I wanted you guys to see. So that's why you have the 2 z values. It's for the lower and the upper. So 1.23. What's my mu? What's my standard deviation? And close it off, and voila. That's how much area is there. You guys try it yourself. 0.6640, which should be the answer. Okay, hopefully that was good. We will finish up on that right here. Let's take our 10-minute break. We'll come back to finish off the rest of the sections here. Before we go for break, maybe just do one more just to, oh, let me finish this off here. So there it is, the area to the left of 1.3. If you did it by table, what you would do is you would take area for 1.23, which is 0.8907. And what we have to do now, we have to actually subtract off this area because now we have too much. It's almost like everything's blue right now. So what we're gonna do is we're gonna take off the sandy color area, the beige color area here. And so if we subtract that out, we got to figure out the value of that. So 0.2266, and we subtract out gives us 0.6641. Same thing that we got on the calculator. Okay, one more for you guys to try. There it is. Can you give me the area that is between a negative 1.5 and a positive 1.25? All right, do them by calculator here, if need be. Try it. And I'm going to do that as well. Let me get rid of that so it's not in my way. So distribution number 2, negative 1.5 comma 1.25. mu is 0, standard deviation is 1, close it off, and by calculator, it's so much easier by calculator. So clicking on that, 0.8275 is the answer, and we have ourselves the area. All right, let's finish off the way the book, there it is. There's the area that we're looking for, and then doing it by table 0.2875 would be the final answer there. All right, and let's go on to the next section. All right, let's jam. This is section 5.2, normal distribution. And what we're going to work on is just finding probabilities. A little more, so that one was just kind of getting used to the curve itself. Question, how do we find probabilities for problems themselves here? So sure, I think we only have like 3 problems here. That's good enough for us to sort of see that, and then we'll jump back going the other way. So all yours to write if you would like. Even shorter here. Okay, we jamming? Let's go. I'm going to go to this one right here. So 1, I think 2, I think 3 examples. Here we go. So there it is. Another thing that's randomly distributed. National study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. That's cool. A college student with a job is selected at random. Find the probability the student works for less than 4 hours a week. Now getting to the usage of this here. Out of total curiosity here, raise your hand if you do work outside of school. 1, 2, 3. Okay. Average work, 22 hours ish. Oh, awesome. Okay. Average work, about 22 ish hours or no, or less. You could do less. You don't have to agree with the data. Okay. All right. I'm thinking back to my college days. I think I worked about the same. I think I worked right about 18. Yeah, it was 18 hours I was closing for. Okay, let's jam with it here. So now the question is this: can I figure out the probability of a student that works less than 4 hours a week? Assume that the length of time college students work are normally distributed and represented by the variable X. Let's jam. Let's go with it here. So first things first is we have to figure out how to convert this to a z-score. We just practiced the z-score, right? And so I think we remember there was a formula for z-score, wasn't there? Anybody remember the formula for the z-score? Z equals? Perfect. Okay, so value minus the mean divided by standard deviation. Let's go with it. In fact, let's draw it out if we can. So let's see if this makes sense. If we were to draw it out like this, and it was normally distributed, here's our 22 about right there, right? We're trying to figure out what's the area that's to the left of this piece right here. And that's going to be our probability. Probability of a person that does that. So kind of interesting. Let's kind of talk about the whole idea here. So I have an area of 1. True. And I'm thinking about, that if the area is a portion of the area, but if I think about, instead of area, I think about people, right? Let's say there's thousands upon thousands of people, right? So out of 1,000 people, if I can figure out the percentage of the area that's there, I can think of the same amount as the percentage of people that are there at the same time, right? So area equals people, area equals data, area equals everything I want it to be. So we'll do that. So 4 minus 22 is actually negative 18. Negative 18 divided by 9 is negative 2. That's cool. So all yours, guys. Can you guys give me the area to the left of negative 2? for a z-score, or negative 2.00. We were just doing this. I think we can. Say again. Yeah, I need the area. Area that's less than. So I got a z-score of -2. So I've converted this from a normal distribution to a standard normal distribution, right? I just didn't graph it. So what's my area value? I'm going to look it up by calculator. Is that right? Look it up by calculator, hopefully, right here, because I'm going to go clear. I'm going to go to second distribution, number 2. I have a z-score of, oh, hold on. I'm going to go from -1,000, right? Or 10,000. My ending is at -2. Mu is 0. Standard deviation is 1. Close it off. And what'd you guys get? Point. Okay, let's jam. This is what I got here. Awesome. 0.0228 looks like, if we're going to go 4 decimal places. Is that what everybody else got? Raise your hand if you did not get that. Okay, can you guys convert that now real quick here? So we think about area right now. Now let's switch it down to thinking about people. And let's think about switching it to percent. So a decimal of 0.0227, what percent is that? Actually 0.228, right? Because of the 5 in the back. I think we moved the decimal over twice, right? Move the decimal twice over to the right. Boom, boom, boom. And so this little decimal goes right here, 1, 2. 2.28, is that right? If you really want to do it by calculator, not mentally, you could just multiply by 100. That's fine. So I got myself a 2.28%. Absolute. So area now translates into people, and the portion of the area translates into percentage, which about 2.28% of the college students that work less than 4 hours a week. We good? That's kind of what we're saying. Okay, rule of thumb. Rule of thumb is if it's less than 5%, it is unusual event. So our cutoff is going to be 5%. Okay, we good there? That was going off to the left. True? Cool. Let's do another one here. So notice we convert from something that's normal distribution, we convert to a standard distribution, which is the z-score. We calculate the percentage that's left, or the probability that's left out of 1. We change it to 100 to a percent, and we apply it to the problem itself. Okay, all yours. Can you go from beginning to end? Here it is. Survey indicates that each trip to the supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. That's like a lot of moms, because there's no way I spend 43 minutes in a supermarket. That's like moms with kids in tow, and they're like, okay, this is my one chance to go to the supermarket right here. Okay, 12 minutes. The length of time spent in the store is normally distributed. That's what we need. And it's represented by the variable X. So find this. Find the probability that the shopper will be in the store for each interval listed below. Okay, that's cool. And then think about, so each part has an A and a B. So think about the probability that the shopper will be there between 22 and 52 minutes. And then part B says if there was 200 shoppers, how many expect to be in the store for that time interval? Okay, see if that makes sense in your mind. So just like we did on the last one, we're going to convert everything to z-scores, right? We're going to figure out the area that's sitting there. We're going to convert that area to a percentage. Then at least we know the percentage. And then from the percentage, we can now that we have 200 shoppers, now we can actually indicate how many we expect to be in the store. Okay, so all yours here. First things first. Given the information, can we convert 22 minutes into a z-score? What is 22 minutes as a z-score. All right, talk to me here. So this is, I'm going to call this z-score 1. Better yet, I'm going to go like this here. I'm going to go like this. Z1, our beginning z-score is, give me some numbers here. 22 is the lower end, minus 43. Standard deviation, 12. And if you do that here, 22 minus 43, negative 1.75. Yeah. Just do this to calculate. Yeah, 21 is it, right? Negative 21 over 12, which gives us a negative 1.75. Perfecto. Z-score number 2. Same exact process, right? Minus 43 over 12. And what is that one? Is that 9? 9 over 12? Uh-huh. And it corresponds to what z-score? 0.75. Okay, that's cool. I got that. And then we go to calculator. At that point, I know both z-scores. Normal distribution, number 2. Now we are between a negative 1.75 and a 0.75, 0 and 1, because we're in the standard distribution. All right, talk to me. Is that what you guys got here? 0.7333. And so it doesn't ask for the percentage. It says, what's the probability? So let's write it out the correct way here. So let's do this here. Probability. Let me kind of write out the terms here. Remember, P stands for probability, right? Probability that our X value is going to be between 22 and 52 corresponds to a probability of a z-score being negative 1.75 to 0.75. So I'm changing from X, I'm changing to Z. We're good? And then I just did all this work here. And what that turned out to be was a 0.7333, I believe, right? Can you guys check me on that? Was it 73%-ish? Okay. That's part A. Part B says, if I had 200 shoppers, how many of those shoppers would be in the store for that duration of time? So I already have the probability, right? About 73% of them. So now we just take that and we say to ourselves, okay, if that's the case, then it's going to be 200. That's why probabilities are important, because you can just plug them back in. You can do all the calculations you need out of that. And I get myself, you guys help me out here. What is that? Times that. Okay, 1.46.66. So roughly, rounding off, gives you 147 shoppers. Okay, are we good there? Done. We've converted that. We looked at area. We figured out our percentage of the area. We converted that to human beings, and out of 200, we should account for that. About 147 of them would do that. Okay. All right, then your job now, very similar to what we've just done before. Can you find the probability that a shopper will be in the store for more than 37 minutes? And after that, then find, if you had 200 shoppers, how many of them would stay in the store for more than 37 minutes? All right, what I like to do, just to kind of get in the habit of doing, so instead of just crunching numbers, is just build a little graphic real quick here of this, because it gives you a sense of seeing it visually as well. And so if I was to build a graphic of it, it will kind of look like this right here. 43 is the average. I do a quick little curve. I label my 43, bless you. I give the standard deviation about 12. Okay, that's cool. And then you guys talk to me. What did 37 give you for your z-score? Cool. All right, z-score, x minus mu over standard deviation gives us 37 minus 43 over 12 and about a negative 0.5. Perfect. So half a standard deviation away. That's what we're looking at. Cool. Okay, so do like we did last time here, doing the numbers themselves for part A. So P, probability of X being less or greater than 37 is the same thing as the probability of Z being greater than negative 0.5. So if you did it by table, you would have done it like this, 1 minus this probability. But we're doing it by calculator. So again, should have got 0.6915. Raise your hand if you got that already. Cool. 1, 2. Okay. And let me try it as well on the calculator here. Second distribution, number 2. Let's see, we're going off to the right this time. So my lower one is a negative 0.5. That's my lower bound. My upper bound is 10,000 this time. 100,000, 1,000, whatever, as long as it's a big number. Okay, so from negative 0.5 on out, the middle 0, standard deviation is 1, close it off, click enter, and voila. Is that what I got down here too? I did, 0.69146, so 15, there it is. Part A is done, 69-ish percentage, right? Okay, how many shoppers then? What does that translate into? 200 shoppers would translate into how many people? Perfect, just multiply that. What you got is your probability times 200, 138 shoppers. You would expect to be in the store for more than 37 minutes. Okay, one more. Okay. Third example here. Okay, everybody okay with this one? Everybody finished it off? Let me go back. All right, let's go into health stuff here. Triglyceride levels. They're a type of fat in the bloodstream. The average triglyceride level in the US for adults 20 and older is 97 milligrams per deciliter of blood, I assume. I assume triglyceride levels are for adults who are at least 20 years old are normally distributed. So again, we can use the normal curve again. We're just assuming it for now. Standard deviation is 25. You randomly select US adult who is at least 20 years old. What's the probability that person's triglyceride levels is less than 200? And it says triglyceride levels less than 950 milligrams is considered normal. So anything above that, you're good. All right, all yours, go for it. One last time, this section, find it for me. Same stuff we've been doing here. We want less than 100. So X value would be 100. What's my mu value? 97. What's my standard deviation? 25. Absolutely. Just you get those 3 numbers, you're good. Just want you guys to try it independently. All yours. Go for it. And this one, again, is actually a real known statistic. It comes from the JAMA Cardiology magazine. It's the journal, think of American Medical Association, I think. Okay, I'm going to try it here. Let's see what we got. So I'm going to draw it out. This is the way I would do it. Draw it out. I'm going to say, look, I need, that's 97 right here. Mu is 97. Standard deviation is 25. And I'm looking for X value that's less than 100. Or the probability of X value being less than 100. Again, I like to draw it out just sort of see what I see. So I'm really looking at this little line right here, true? That's my line. And then anything that is less than that line. So it's all this stuff right here. That's what I'm looking for. So I know I'm going to get a positive Z value. Everybody agreed? And a slightly positive Z value. All right, let's go for it then. So Z value is X minus mu divided by standard deviation. I got 100 minus 97 divided by 25. And that gets me a Z-score of 0.12. Also, I know this is normally distributed. So the calculator way of doing it, again, is negative 10,000. I'm going up to a 0.12, 0 and 1. All right, anybody gonna answer yet? Perfecto, yep. 0.5478 or 775. So we're gonna round it off to 0.5478 would be the way we're gonna write it. That's cool. All right, so we just did it by calculator. We could do it by table as well, right? The other stuff that's kind of known out there, just to sort of let you guys know. Here's your kind of technology pieces here. So the T84 plus calculator, T83 works just fine. There's 3 more that are sort of used in the industry here. So Minitab is another statistical software. StatCrunch is another statistical software used in industry. A lot of in education. For the online students, they have StatCrunch built into their online publisher site stuff. So they do number crunching with that. They plug those in. Or Excel. If small businesses that can't afford these guys here, they'll just use stuff in Excel to look at standard deviations of things or look at what's happening here. But anyways, we got the answer, right? 0.454775 or 0.5478. That's what we got. Cool. Okay. What do we have? Okay. So here it is, last section of the day. Has your mind been blown at least a little bit here today? Okay. So normal distributions, finding values. That's what we're going to look at next. At 2.5, oh sorry, 5.2, 5.3, they almost have to be taught together because you're going one way and another way. Okay, we're going to do this kind of quickly here. So first things first, don't need to write down the next slide. This is kind of a thought through process here. So in the previous section, what we did is we did this. We normally went from the X value to the Z value to probability. Is that true? Yes, everybody shakes their head. All right, cool. This section, all we're gonna do is we're gonna work our way backwards. That's all. Go from probability back to Z value, back to X score if need be, okay? That's all. We're just processing this. So let's begin. Problem number 1, go for it. Find the Z score that corresponds to cumulative area 0.3632. So of course, we're going to do it by table, right? And then we're going to do it by technology. So 1 and 2, let's go for it. If we did it by table, let's do this here. How about graph this out first? Can you guys do just a quick little graph of it? What will the graph look like? Are you above 50%, less than 50%? That's kind of what you're judging-ish. So when I graph this, when I draw this out, I would probably go something like this. I go that, I don't know. I know that the middle is going to be 0, right? Because I'm going for a Z score. So I got that on my hands. Let's see, 34. Hey, you know what? If I go 1 standard deviation away, that's 34% right inside here, isn't it? Out of 50, right? I want 36% going from the left. So what do I have left? Don't I have like 14% left? So I'm thinking I'm kind of like right here. I'm thinking like I'm about like right here-ish. That's what I'm looking for. I'm looking for an area. Point 0.3632. See if that makes sense. Are we good there? Somewhere in that gauge, just for you to good sort of gauge it where you should be. All right, let's go by table and then we'll go by technology. Let's jam. By table, here's what we do. We find 0.3632 on our table. So you should assume which table you're going to use. If it's less than 50%, you're going to use the negative z-score table. Above 50%, you're going to use the positive z-score table. So in this case, I'm going to flip to the negative. And I search in the middle. How about that? It's all this middle section right here. I'm searching for a 0.3632. And once I find it, then I say, okay, that's cool. I'm going to go to a z-score, starting to write it down, a negative 0.3. And then I just need my 100th digit of 5, and I'm good. So negative 0.35. I'm done. Okay. So Mr. Ngia, that's great and dandy. How do we do it by technology? Okay. We'll do it that way then. All right, on is on. We're going to go back to our distribution button right here. I'll wait up for you guys. Instead of picking 3, I'm sorry, picking 2, we're going to pick 3 now. This is called the inverse. We're going to go the inverse way of our normal distribution. So number 3 is what we pick. All right, and we're going to pick, let's see, 0.3632, comma. We're going to say our mu is still 0. Our standard deviation is still 1. Close it off, click enter. And we got ourselves, is that what we have? Yeah, again, it's not exactly 0 or negative 0.35. It's negative 0.3499, but pretty close. Okay, so there's the technology piece to it here. Cool. Okay, everybody got that? I can pause the recording if someone didn't get that, but raise your hand if you need help with it. Need help? Going once, going twice, or forever hold your peace. Okay, cool. Awesome, love it. Next one, all yours now. Find a z-score that corresponds to 10.75% of the distribution's area. Ooh, to the right this time. Just trying to mess with you guys now. So I'm going to draw it out now. Drawing it out means this way right here. Zunk. So this point, I'm all the way over here. So z is equal to 0. I'm sorry, mu is equal to 0. Standard deviation is 1. That's cool. We're at z-score time. I'm like right over here. There's my z-score. I'm like right here, right? Because 10% is going to be just like right here. Roughly about 90% has to be included that way. Here's our bummer. Calculator doesn't do stuff like that. Calculator only goes cumulative area, right? From the left to the. All right, so let's do this here. Let's convert this down to a probability here. So 1075, is that good for you guys? Let's convert it to probability. On your calculator, maybe just grab and get 1 minus 0.1075. What's that answer? .8925. Everybody agree there? Okay, cool. Okay, at that point, go for it. You can do it by table if you like. Or you could do it by calculator here. Let me go, bless you. Let me go to table here first. So on the table, if you did it, you're going to find the 0.8925. And that corresponds to a 1.24. And did you guys get that on the calculator? So second distribution number 3 for inverse normal distribution, 0.8925, 0, 1. Close off the parenthesis, 1.24 looks like. And that's exactly what we get down here. Cool. Okay, just going backwards. That's all. That's all we're doing here. The other thing that we do with this one really lends itself to doing is percentiles. So let's do this here. So if you guys took a standardized test, and raise your hand if you took the SAT. Anybody took the SAT? One, I think it was like one person. Yeah, I think that's right. So percentile ranking. When you got out of high school, I know it was this. It's always this way. So you got a percentile ranking of your of how you exited high school. Usually it said like you are 125th out of 300, right? And then it says percentile ranking is 82 or something like that. So this one corresponds to percentile ranking of 5%. That's what I want. The z-score that corresponds to 5%. Let's draw it out first though, guys. So if you want to put P5, drawing it out means you look like this. And then you're gonna go 0, standard deviation is 1. And we're gonna just put a bar right here. And we're gonna say that has to be 5%. Okay, let me show it to you by table because this is important. This one's an important one right here. If I were to look at the table markings right here. Oh, real quick here, sorry. This would be what? This 5% will correspond to a 0.0500. Is that right? You guys okay with that? Cool. If I look at table 5, and I'm going to look myself right here, real quick here, 0.0. Oh man, this is so strange. Still finding it. Still trying to find it. Oh yeah, right here. So I have this. I'm looking at the table. I have 0.0495, and I have a 0.0505. That's what I have on the table. And so if I look this way on my table, I get a negative 1.6. And I look this way up, I get a 0.05. And I get a 0.04. What in the world am I going to make out of this? Notice it's exactly 5 units if you just add 0.0005, or if you were to subtract 0.0005, you actually would get what you want, which is the middle. That's no fun. All right, let's do it by calculator, see what we get here. So it looks like we're going to be kind of in the middle, right? In the middle between a negative 1.65 and a negative 1.64. What is the middle of negative 1.65 and negative 1.64? Negative 1.645. Okay, let's do it by calculator here. Doo-dunk, doo-dunk. Inverse operation number 3, 0.05. You can tack on the extra 2 zeros if you like. We're going to go with mu 0, standard deviation is 1. Close it, turn it. Oh yeah, it's actually a little bit less, but once you round it off, it's actually, yeah, negative 1.645. Corresponds to the 5%. That's actually one that's going to occur a lot in our data sets here. Negative 1. The z value of negative 1.645. Okay, there's that. Next. Can you guys give me the z-score for the 50th percentile? All yours, have fun. Cool. All right, what'd you guys get? 0. How many did not even do it at all and knew it's going to be 0? Okay, cool. Yeah, 50 percentile is half of it, right? So if you go to taskbar, boom, that's easy enough. Number 3. So 0.5000. The mu is 0, standard deviation is 1. It's going to give you a flat 0 because you're looking at 50% of the data. That's awesome. That's 0. So there it is. Z equals 0. Okay, and one more for this type. 90th percentile. Give me the 90th percentile. All right, let me try it. Let's see. Let me graph it first here. I want to graph it here. So we're looking at this here. I'm looking at this right here. 90th percentile. And notice I'm kind of getting close to the x-axis, but I'm not touching it, or the z-axis. So 90th percentile will be like right here, right? This is like this right here. So that's going to correspond to 0.9000. True. That's what I'm looking for. All right, inverse number 3, 0.9. Okay. I'm not even going to put the 0.000. There's no point to do that here because that's going to correspond to there. 1.28. Are we good? Raise your hand if you're not good. I'll come by and check. Not good or good? Good. Okay. 1.28 is perfect. Z-score 1.28 is awesome. Okay, so notice we've done so far. We've gone from probability back to the z-score, right? Okay, we've got to do one more. We got to go now from the z-score now back to the x value. So how do we do that? Oh, let me jam from here. We do it by, if you want to write down the formula, that's cool. So x is equal to mu plus z times sigma, or z times standard deviation. There's a formula. Question is, how do you get to the formula? That's the next question. All right, remember our previous formula. Remember z was equal to x minus mu over standard deviation. Can you guys do some algebra over here? Instead of having it solve for z, can you have it solve for x? What should we do? Multiply both sides by standard deviation. Perfect, because you want to kill off or cancel off the standard deviation on the right-hand side. So there's that. Leftovers are x minus mu. Next, add. Absolutely, add the mu to both sides, and then you get x by itself. So now it's mu plus standard deviation times z equal to x, and then we're going to flip it around. So x, and then it doesn't really matter if you put the z times the standard deviation plus mu or mu plus, it doesn't matter which direction, right? Just the book had to pick which way they're going to do it. So that's the way they picked. That's cool. Okay, so really, there's the next step. And we're going to put them together here in just a bit here. So just some practice. Let's do some practice items real quickly here. So can you convert z-scores into x values? That's what I want. So all yours, can you convert a z-score of 1.96 using this formula? Give me the x value that corresponds to this guy. If you know this is a veterinarian records the weights of cats treated at the clinic. The weights are normally distributed. And so the average cat weight is 9 pounds. And the standard deviation for cat weights are 2 pounds. So z-score 1.96 is going to give you x value cat weight of what? Perfect. Just plug into a little formula right here. 9 plus 1.96 is you just use this formula times 2. Punch it into calculator real quickly here. 12.92 pounds. We're good. Okay, do that on a calculator real quickly here. I want to see if anybody has issues with it. If not, we'll keep on going. I got a positive z-score, a negative z-score, and z equals 0. That's all. And we should get familiar now with what z equals 0 means. Okay, boom. Answer for number 2, a z-score of negative 0.44 is perfect. 8.12, 8.12 pounds is good. And the z-score of 0, which means we're not going any direction. We're at the average already. Just a big old 9, right? We didn't move anywhere from the 9. So notice for the first one, we go out to we go towards the top. We go positive away, right? Because the z-score is negative, we actually have to go down from the 9. For the third one, we don't go anywhere away from the 9. Okay. Okay. Boom, boom, boom. So I got a few people still writing it down. Go for it if you need to write it down. And so what we really are doing here, if you kind of think about it, all we're just doing, we're just changing a scale, right? Because the standard normal distribution and a normal distribution looks the same. So if you think about it, this is kind of what we're doing right here. The graph is the same. The z-score is just what we use to find values, but the x-score is just a scale change, right? 0 corresponds to 9. This guy corresponds to this one. This corresponds to this, but it's literally, it's the same graphic anyways. They're just changing scales. Okay, so 1, 2, I think 2. All right, so all yours for this one. Boom, scores for the California Peace Officer Standards and Training Test. They are normally distributed. The mean is 50 on the score, so you got to score 50 to get right in the average. And the standard deviation is 10. So an agency is going to hire applicants with scores in the top 10%. Question is this: what's the lowest score that you have to earn but still be in the top 10%? That's what I'm looking for. Boom. So let's see, if you're in the top 10%, that means you are in the 90th percentile. Is that right? You got to be at 90% plus. That's cool. Okay. So that's cool. So there it is. The graph should look like this if you haven't done it already. Z-score of 0 is the middle. And I kind of gave you the answer there. That's no fun. I'm going to back it up. So there's my graphic right here. Again, top 10% is over here. That means I'm looking for the 90%. So I'm looking for 0.9000. My z-score corresponds to z equals 0. Standard deviation is 1, but I'm trying to figure out what that z-score is. and then convert that z-score to an x-score. So we got two things to do here. What's my z-score that corresponds to 90th percentile? 1.28. Everybody agreed there? Okay, you guys looking at the board here. So I'm not sure if we're working or not here. So I'm going to go this way. This one, notice it's the same exact answer we got before, right? Look at that. 0.901, is that right? Isn't that the same answer we got before? So 90th percentile is always going to be a 90th percentile. It's always going to be 1.28. That's why it's a standard normal distribution. That's cool. Okay, I got that. So then I have this equation. Is that right? X is equal to mu plus z theta. So mu is 50 now, plus 1.28. What's the standard deviation? About 10, yeah, 10, okay. So 50 plus 12.8 gets me 62.8. And assuming the scores are, integer values, right? You get a 50, you get a 51, you get a 53, right? So what score must the police officer get? I think I heard it, 63, huh? Because they have to be above 62. 62 is not the cutoff. It has to be a little bit above. So the cutoff then would have to be, you'd have to score at least a 63. Not all police officer training, have a extended family members when it's nursing, the TEAS tests. When it's nursing, that's exactly what it is. The higher score you get, the better probability you get is being selected, but you got to score, I think, at least 70. Most schools accept at least a 70. If you don't at least 70, then they're not even going to look at you, kind of thing. So stuff like that. And it's same concept here. Okay. All right, I'll give you, just because I like you guys, I will give you the quick way of doing it. So notice what we did is we looked at our calculator, we found the z-score, right? And we took a calculator and then we had this little formula to give us the answer. But notice each time you put this stuff into the calculator, you have to say what your mu is that right? And you always have to say what your standard deviation is. Hold on, let's back up then, hold on. What? So let's put this in again. So I'm gonna go distribution and do it with me here. Number 3, I wanna be the 90th percentile, but my mean is 50, is that right? What's my standard deviation? 10, is that right? That's so cool. Close it off, click enter, and I love it. So all this time, Mr. Ngiev made us do this in 2 parts, that we could have been doing this in 1 part. Mr. Ngiev, that's cruel. Maybe. It maybe is cruel. All right, with the 3 minutes left, give you one more. Can you do it by calculator? Can you calculate this right here? All yours. Can you do it by calculator? Randomly selected sample of women ages 20 to 34. The mean total cholesterol level is 179 milligrams per deciliter. Standard deviation of 38.9. Assume they're normally distributed. Find the highest total cholesterol level in a woman ages 20 to 34 can have and still be in the bottom 1%. So now we're looking towards the bottom. So if you think about bottom 1%, are we already talking about the left side? Right? We're already talking about here. we're already talking about, oh, let's put this in. Let's put this. This guy's mean is 179. I have a standard deviation of 38.9. Boom, boom, got my numbers. That's cool. And whoa, the bottom 1%. That means like she's all the way over here. That corresponds to 1%. As a decimal, isn't that 0.01? That's 1% as a decimal. Okay, all yours. Tell me if you got the answer. Go. All right, so inverse of the normal distribution. Ding, ding. Number 3. I'm going to be at the 1% mark of a mu of 179. Standard deviation of 38.9. Click enter, click done. I got an 88.5. That's what I have there. But final answer is what? So what is the highest that they can have? And it seems like they go by integer values. So 179 is integer value, right? 180 is integer value. 181 is an integer value. So if 88.5 is kind of like the cutoff, what does the lady have to have in order to be still in the 1%? Yeah, we're gonna go lower, huh? Right? We don't round them off. We don't do that. We actually have to go lower. So we go 88. So milligrams, mgs per deciliter. So if she has that, she's still in the bottom 1% of it. Okay. And we are done. Right on.